Okay, we'll get started. There we go. All right, well, hi there. My name is John Poyser, and I am the Senior Director of Customer Success for CodeZero, and I'm really pleased to be here talking to you all in Austin. It's a really nice place to visit. Anyone here local to Austin? Sweet. All right. Okay, well, I'm from Vancouver Island, Canada, and almost far west as you can get and still be in Canada. And it's a coincidence that I'm living on an island right now because I was also born in Kingston, Jamaica. So, one thing that islanders have in common is that we like to tell stories. So the format for this, I know we're in the workshop room, but this is a bit of a talk with some deep dive in some use cases and then hopefully a live demo at the end. And I've got slides at the end where we have some sample projects, and you can try all these things for yourself after the talk as well too. But the premise for this talk is that we make it too hard to work with Kubernetes. So out of all your teams here, I'm assuming everyone here is, if you're at this conference, you're working with Kubernetes. How many services do people typically run? Anyone who has like less than 20 services? Okay. How about more than 20? More than 50? Okay. Well, one of the things you probably know is that Kubernetes is really complex, and it has super powerful, incredible potential, but often we forget how steep the learning curve is for our new teammates until they come on board and we find out how long it actually takes them to get going. So one of the things we think is that right now we're developing microservices wrong. And at CodeZero, we think that there is a smarter, easier way to develop collaboratively. And based on the teams who've tried doing it our way, they don't want to go back to the way that they're doing it. So I assume that if you're here, you're using Kubernetes, and you probably have a service mesh that's complex. And the old way of doing things with the code deploy test is really complicated. So with our service, you can code enhancements to service A, but you probably need access to some of the in-cluster dependencies. So what you do right now is you merge that change and you push it to your integrated testing environment. And then often sometimes it'll work, but sometimes it actually won't. And then you have to go back and you have to test. And then you do this whole iterative process where every time you want to test something, you have to push something up to your shared environment before you can actually test because of all the complex dependencies. And this is really quite slow with that fixed test diagnose. So why don't we actually go and run all this stuff locally? Well, that worked back when we were doing things on a monolith or for a few small services, or maybe even at this scale. But with larger teams, that mesh is really, really complex, and it's not ideal. And we think we have a better way. So with CodeZero, what we want you to do is we want you to collaborate and test and preview before pushing everything through to your pipelines. So what CodeZero lets you do is it lets you consume an in-cluster service locally on your machine, and then you can also serve a new variant of your service out to your cluster. So before you would code and deploy, and then you'd wait and wait and wait, and then have to go back and revise. And what we'd let you do is we let you actually do all that rapid iterative testing earlier. So your teams can actually be testing in cluster using their local development tools. Different teams can be testing different combinations of services in any combination. And really, there's a lot of different possibilities about how you can actually use this service. So some of the common challenges that developers are facing right now is because we're moving more and more from local development and monoliths, we're gaining scalability and granularity at the expense of ease of development. So what we have is we offer an infrastructure tool that's enhancing your developer collaboration, and it's allowing you to do secure testing without having to go through and do a whole lot of log diving. You're actually testing in real time with your local testing environments, and without using a whole lot of shadowy workarounds and fudging your environment configuration. So we sit adjacent to your existing CI/CD build pipelines, and we let you safely consume and intercept services in a cluster. We're allowing you to work with different variations of services in production-like environments and debug together in real time. And so essentially what we're doing is we're traffic shaping, and we're letting you move your traffic to and from your machines and not having to actually replicate containers locally. So why did we build this? Well, we wanted to make it really easy to develop microservices without requiring all your team requiring deep knowledge of your services or large changes to your environment. Because you're always going to have a core group that is going to understand Kubernetes and deeply understand your infrastructure. But as your team grows, your newer members, let's say like a front-end developer, they shouldn't have to know the nitty-gritty of how all these services work in order to get their work done, any more than everybody in your house doesn't need to know how the plumbing in your walls works in order to walk over to a tap and get hot and cold or a mixture of water. So with the rising complexity of environments, productive coding time is decreasing. LinkedIn did a survey and they said that a bit over 50% of developers are reporting that they spend less than 3 hours a day writing code. So the rest of their workday is spent on non-coding tasks like testing, security management, and container orchestration. And of course meetings, but we can't do anything about those. So I'm going to give you a real life example in detail from our host Civo. So Civo are actually using our product, and they recently had a project that involved their front-end team, their mid-air API teams, and a back-end machine learning team. So it required multiple infrastructure components. So they had Kafka, Redis, a large number of databases, and some GPU-backed Kubernetes clusters. So all of these resources were needed all working together, a front-end JavaScript tier, several core APIs, and some really large machine learning models, and they all needed to communicate through REST, gRPC, or flowing data through different queues. So before CodeZero, their front-end team, they worked on web interfaces and they mocked up all their responses from the API. And then the API team would make assumptions about what the back-end team was going to need. And then the machine learning team, they operated independently because, they're Hogwarts wizards working in the back there. And everybody worked on all their teams, their processes and their pieces remotely. And then after 2 weeks, they all came together. And then during integrated testing, they were uncovering all kinds of blocking issues because there were small little changes that happened since we all agreed how we were going to work beforehand. So they had some data type changes, they had some unexpected data fields, and all these small little changes of requirements would require they would go back and they would start from the beginning again, and they were having to test. So once they saw a demo from, oh, by the way, this is Narayan, our CTO for CodeZero, and he'll be helping me with questions and some of the demo later on. But once Dinesh, the CTO from Civo, saw a demo, he changed the way that their teams were working. So now they were able to restructure everything so that they could collaboratively and test very iteratively and pair program together. So their API team would first develop a response endpoint with dummy data, and that would allow the front-end team to work with real API responses. The initial deployment, even though it didn't have any tests, it enabled quick collaboration and adjustments. And then the front-end team, they could submit their forms and receive responses without even having a fully functional database. Different teams would test their changes collaboratively. They would communicate via Slack, and then they would coordinate all their immediate adjustments. And then the API team would take that feedback and they would push new variants into the cluster, enabling all those developers to rapidly test the changes against the updated API endpoints. So now they could all test how everything all worked together, and when they were more confident that everything was going to work, then they could push it through all the automated pipeline, have all the automated testing, and then they could rapidly test that the iterative process, and it really reduced their integration challenges. And this is one of the teams that have said that they don't want to go back to working without having access to this collaborative testing early on in the process, because the problem is our slow development cycle. Often the time that it's taking to code and then publish your PR, wait for your code review, merge it into the CI workflow, and then get deployed to staging. It's a long time before you can before you can actually test and see if there's any issues. You figure out the issue and you have to go back to the start and start the whole process again. So it's a really slow process. And the problem is that our local development, it just can't scale. Over 80% of teams are running 50 microservices, and over 67% are running over 200 microservices. So dev teams are always having to mock up services and run everything locally, which requires a lot of engineering time. Local hardware may not have enough resources. Now that we have people who are trying to work on large language learning models and machine learning, you just don't have that GPU horsepower locally. You have to work on things in the cloud, and the access is very restrictive. But with CodeZero, we make that remote locally accessible. And you can just grab that service, pull it down locally, and only work on the traffic that you need to work on your local environment. So these are some of the underlying concepts of how things actually work. So you've got your service up in your cluster, and it may have some upstream inbound traffic. There's downstream dependencies on that traffic as well. And then typically you're now working on a service and you've got a new version and you need to enhance it somehow. So what we do is we allow you to run that service locally. We call it a variant. And then when you're actually ready to go and test it, you can consume some traffic from an in-cluster service, test it against your local service. And then when you're ready, you can also serve up a variant of your service into the cloud without any need for any deployment. You can just temporarily push it into the cloud, make it available for the rest of your team to work on. This is our new UI, and we give you a web app, a web console, and CodeZero works across multiple clouds. You can have team spaces sitting over in Google and Amazon, Azure, even on-premise or on Civo. And we automatically discover and filter all of your services in one place, letting you look at and just see exactly what you want to work on. And then instantly you can see what's running where locally, production, pre-production, or even something running on a colleague's machine and interact with it, all without having to change any of your environment configuration. So really the magic is that you can create these really complex combinations of test topologies within seconds without deploying anything in real time using live environments. And you can go to our website, or you can come talk to us afterwards if you want the details of exactly how things work. But essentially there's just three main components that are running. There's there's a service running locally on your local workstation. There's a team space that's running in your Kubernetes cluster. And then we maintain a hub, a central cloud that's hosted by us, that's communicating all of this traffic. But if you want, you can run that cloud hub on your own infrastructure as well too, if you like. Okay, so what I've done so far is I have set up a Civo cluster. Oh, before I go, are there any questions? Okay, so I've set up a Civo cluster, and so there's a Civo cluster, and we have a sample project on our GitHub. That's our GitHub is C60, and the sample project is creatively named sample project. And what it's doing is it's useful for engineers because it has a lot of, it's essentially a whole modern microservice environment in one little package. It's got a load balancer, there's one ingress point, there's a front-end service, there is a core service, there's some APIs that have dependencies, some that don't have dependencies, there's a Mongo database and a Leaf service, and you can have all kinds of traffic running in here, WebSockets and TCP, UDP, HTTP, all mixed in together. So there's a full multi-level application that's represented here, and we have a number of tutorials that are also on the website that let you work with this. And so what I'm going to do is I've created a team space in our environment. I've deployed the sample project into our Civo cluster, and I've installed CodeZero locally. So let me just stop this and I will share. Okay, so running over on Civo Navigate, the team space is here, but again, you could have multiple different environments. You can have a dev environment, a pre-production environment, as well as your production environment, and you could also have multiple different clouds. So all the namespaces are represented on the left-hand side here, and then these are all of my microservices that are running in the environment. And I'm going to filter it just to show only this sample project. And I can also set my primary namespace here. And this web app is going to be available as a desktop app as well too, but we also have a command line interface. So right now what this is showing is I've got my front end in the cloud, I've got a core, the database, I've got the Leaf service and some sockets. And right now none of that traffic is all coming locally. So I've got K9S over here on the right hand side, and it's showing the same services as well too in the cloud. And down here on the right, so I mentioned that we're doing traffic shaping and we're doing split DNS tunneling. So on the right hand side, I've got my host file, which is showing just our local daemon. And I can reach up into the cloud, and if I want to work on the front end service that's in the cloud, I just click on consume, and in real time over on my host file, you can see that now that sample project, instead of being having to go and get into the cluster and go through the different ports to get in there, it's now locally available, and I can literally just hit it locally on my machine just by hitting just the local namespace. And if I stop that, this should break as well. It goes away. It can't connect. If I want to access my database, I just click on consume, and instantly over in my host file, now that local project database is now just available as sample project database. And I can just come and I can run the MongoDB shell, and I can access just sample project database. And now locally, that database is up in the cloud, and now I can just work with it just so I'm running it locally on my local environment. Now let's say that I've got a sample project that I'm running locally. I've taken that front end, and now I want to actually make my local variant available to everybody on my team. I just click on serve variant, and I can choose different ports I want to run it on locally or in the cloud, and I can filter all the traffic on this by user, by header, or I can actually interact with all the default traffic running through the service. I'm just going to hit serve, and over on the right hand side, instantly in the Kubernetes cluster, in the Civo cluster, now that sample project is now available, and everybody on my team sees this nice little image of myself and available. And now if they're running CodeZero as well too, they can also see that service. So I could have a version of my front end service, one of my colleagues can have that version of the front end service, and using this console they can go and they can just pick and choose whether they want to work with the production service or whether my local variant running locally on my machine. So you can create some really interesting and really complicated versions of mixtures of running something locally. I can try out and test against the service that's running on Narayan's laptop over here, combined with my service, as well as in-cluster resources. And it's all available through through the console. In addition, I can also just have a text file which has some Boolean logic about what services I want to have locally and in cluster. And the nice thing about it is that when I'm done with this, I just hit clear, and now all of that traffic is now, it's all restored. My variant goes away. Or if I want to, I can click on consume all, and with the click of the button, you can see over here in the host file, instantly all of those in-cluster services are now all available locally. So I can just go and I can just work with them as though they're a local resource. So in addition, I can also run my my VS Code, my favorite IDE, all my local tooling, and I can put a breakpoint in the code, and I can start and stop the service and run interactively. I can grab the traffic from one of the nodes in a cluster and route it to my local machine and work with that interactively. In addition, if I have let me just exit Mongo here. If I I can also serve up a local service that isn't running anywhere in the cluster, and push and make that available in the cluster environment. Okay. All right. Well, were there any questions about anything that I've shown so far? Sure. No, there is nothing running locally on my machine. I'm grabbing all of these services all locally from remotely in the environment. So there's no ingress available. There's no access to that database available to the internet. I'm going in through the ingress point, but when I come here and I grab the Mongo database service here.
My underlying question is if you're testing on the Mongo database, are any of the changes that you're testing stick, or is there a... They do?
They do. It's meant to be the whole idea is if you're doing something fairly large, like a large machine learning model or something, you wouldn't be able to bring that down onto your local machine. So yeah, they are sticky. So you'd want to do like namespace partitioning or something if you don't want to collide with your colleagues. But the whole idea is we've done this demo of like an iPad using CodeSpace, like just even in a terminal where you have virtually no compute or storage, and your entire cluster looks like it's running on your iPad essentially.
So what's actually stored locally?
Short answer, nothing.
Okay.
What we're doing is sorry.
That's good.
Yeah, well, nothing stored locally, so great for tests, tear down, walk away. It's literally DNS traffic shaping that's running. Yeah.
Great question. All right.
Do you want to go do story?
Sure. Okay. So I'm going to show you the story of. Here we go. So this is Marty Weiner, and Marty is a former engineer at Pinterest, and then he also is the former website of he's the former CTO of Reddit. And so Marty's also an advisory board member for CodeZero, and he personally invested in CodeZero when he saw this because he was really excited about what we do for collaborative services. He saw what we built, and he said, "I tried to do that for 5 years at Reddit, and I wasn't able to do it." So when he was at Pinterest for about 5 years, and it grew from a place that had that nobody had ever heard of to a household name. So they went from running everything as a single monolith to running thousands of monoliths on thousands of servers, all while frantically trying to pull all this apart into decompose their code base into microservices. And they went through when he went to Reddit in 2015, they had 25 engineers, and they had to scale up super rapidly. And what he found was that they not only went from a handful of servers to thousands of servers, breaking everything apart, but they also passed over 100 engineers, 200 engineers, and the communication and the coordination became super difficult. They also had such a large service catalog that they lost that ability to run even a portion of any of their services locally. And they also lost that ability that they had back in the early days of sitting in the founder's apartment, of being able to quickly hack together and collaborate on something and get instant feedback. So when he met with us, he got really excited because essentially we address two of those things in one go. We have that automatic discovery of the service catalog, and we also give you that ability to quickly grab one of those services and work with it locally, and hack together with a teammate really rapidly on a development environment with the push of a button. And then you just click clear, and all of that goes away, and then you can commit your code and put it out into a normal staging environment for your regular tests. Okay. Would you like to see like a real-time debug demo of how this works using your... Well, Narayan likes VS Code, so... Okay.
Sure. Thanks. I can just grab the HDMI.
HDMI? Okay.
Yep.
All right.
Thank you, sir. I'm so glad. I'm so glad Apple added HDMI port to these Macs. So, thanks, JP. I wasn't sure this would work with the campus network, but so as JP showed, here's a service catalog, and we already showed variants. But what I have that's different than JP's setup is I have a cluster with a pod with a deployment that has 10 pods running, and in my setup, when I bring the traffic down, now we're all used to doing port forwarding sometimes into the cluster. The difference with port forwarding versus using our tech is you actually get the in-cluster experience. So what you're seeing on the line highlighted, each time I'm doing a request, the pod that it's hitting is changing. So with port forwarding, you get a hot connection. You actually connect to a single pod in the cluster. And if your colleague deploys a new version or that pod dies, you have to reestablish your port forward. You're actually not getting a true experience of the in Kubernetes cluster network experience. So you're not going through kubedns or anything like that when you do a port forward. Whereas here, what we're doing is our tunnel connects you through kubedns. So you're getting truly a melding of the Kubernetes network with your local machine, with your colleague's machine. So there's that. So this is doing the round robin. And if you do alternative load balancing, if you want to do tests of blue-green deployments of your deployments and so on, you'll get that true experience, which you can't get with pod forwarding. The second piece is what JP talked about was serving up a variant. So the same application, this is two browsers showing the front-end app, and all the front end's doing is polling the various APIs every 2 seconds. And if as JP showed, when I serve a variant, this is what we shared with Marty, and Civo does this occasionally. I'll have to ask Dinesh if they do it in production. But when you do this type of serving of a variant, your production traffic on the left has no clue that you've done this. You've basically taken over our service in the cluster, whereas the requests on the right are stalling. They're timing out because I don't have anything running locally. But let's just bring up a couple of things, a code editor, and I'm going to actually start a service. And let's find the index.js. This happens to be a Node project, but we're language agnostic. And here, I'm just going to attach the locally running project. And what I'm doing here is I'm actually stopped on a breakpoint. Let's see, there, that's me stopped on a breakpoint. And as I refresh both, the service on the right will stall because guess what? I'm in production, stopped on a breakpoint. But on the left, any other traffic coming into your application has no clue that you're doing this. You're doing real-time debugging, not having to look. That's when JP was talking about not having to look through logs and so on. So same application, same URL, two different users, different experiences. So we'll be here all next couple of days here, maybe.
And sorry. One of the really nice, powerful things about this, being able to actually debug it live and step through your own code, is that you don't have to guess and instrument and guess at what's going to have a problem and write things out into logs and then go back, and you know how fast logs get generated these days, trying to find the issue back in the log. You can actually direct the traffic locally into your local environment, and then you can step through the code and pause it anywhere you want and actually look at the real data that's coming through in real life.
And we can show you that.
Yeah, we can give you. We're at the booth just down the hall. If you want to come by, you'll see the looping demo as well too. But any other questions? Okay. All right. Well, thank you very much for your time, guys. Appreciate being here.